Hi, this is Coach Chuck from the National Free Flight Society Youth Development Program, and this is a presentation intended for coaches' clinics, but can also be used by coaches individually or even by team members to learn more about the flight event for 2024 Science Olympiad competition. This presentation is broken into four parts. First, I'll describe the event and the rules, and including the rules changes from the previous year. I'll then look at sources of materials and assistance, building techniques, some basic hints and tips on building, and similar to that, basic hints and tips on flying. The flight event this year is very similar for divisions B and C, with the only difference being the measurement box size. So we'll cover both events together here and point out the differences as we go. The flight event is a pre-build event, meaning you build the device at home and test it at the event. It's for powered indoor aircraft flown for duration. So time in the air is everything. And the device can be made of any materials except for boron fibers. And the plane or the flying device is presented in a box with the outer dimensions specified. So unlike previous years where the plane has to be measured, instead a student-supplied box is measured and the plane must fit ready to fly into that box in order to qualify for the top tier. The score is the best of 2 flights in duration, and kits are permitted, but the planes must be student built. Some changes from last year. The box dimensions were slightly changed, as we'll see in a moment. This is to improve the flyability of the C division plane and to make available a few more readily available boxes so that students don't have to build their own box. Only one box needs to be presented for measuring the airplane. Last year we needed 2 boxes if you had 2 airplanes. The rubber motor size is reduced from 2 grams down to 1.5 grams to limit the flight times. There's no longer a black marking bonus on the planes. There's no longer a build log required, although the flight log is still required, and there's no cover sheet required for the log. The flight log, finally, is now a bonus rather than penalty. Same result, but it gives a more positive spin to encouraging the use of a flight log. A little bit of direction about the event. This is not necessarily a design event. Now, having a measurement box rather than measuring every aspect of the plane leaves the field open for a little bit more interpretation, a little more creativity, but it's still a flight optimization event, not a design event. Most of your gain is going to be after you build the airplane. Therefore, data collection and recording is critical to your success in this event. You need to build light. You need to try to reach the minimum allowed weight, and that's 8 grams in this case, and that's relatively easy to reach with locally supplied balsa wood and materials. You need to build accurately. Crooked and twisted planes don't fly well, and you need to take lots of data, and this means fly a lot. I can't overemphasize how important gym time is compared to build time. Some of the event parameters, the planes may be a kit, they may be built from plans, or they can be a self-design. The only stipulation here in the kits is that no pre-glued or pre-covered parts are allowed. The aircraft must fit in the specified box, and that box is provided by the team, not by the event supervisor. So the team may buy or build a box, but only one box is required this year. In B division, it's 41 centimeters by 28.5 centimeters by 65 centimeters. This equates to a long banker's box, and this is a change from last year being about 2 centimeters longer and 2 centimeters wider than last year's box. So 28.5 centimeters remains the same. There's not much a difference. You could use last year's box and still fly quite well. It's up to the team to make sure their box, even if it's a purchased long banker's box, fits the rules dimension. This is the outside dimensions of the box, not the inside. For C division, it's a larger change, both for availability of stock boxes and for flyability. It's 32 centimeters by 23 centimeters by 47 centimeters. This is 1 centimeter narrower and 4 centimeters less tall than last year's box, but it's 4 centimeters longer. Last year's plane suffered from a very short tail moment, which made it difficult to trim. This year's plane should be a little easier to trim. And this equates to a typical 8-ream paper box. And you have to buy 8 reams of paper, but hopefully someone has those around, or you can build your own box. The box cannot change the shape of the airplane. The airplane must be ready to fly and fit inside the box without flexing the shape of the prop or the plane. Prop has to be mounted. Rubber does not have to be on the plane. The team is responsible to make sure their box is going to fit the requirements, and that will be measured at the event. Don't push the dimensions. If the box is too big, you will get tiered, and it's very difficult for the kids to modify the box size and possibly the plane size once they've come into the competition area. The propeller can be built or purchased. The plane must be labeled for identification. Up to 2 planes may be presented for inspection. And the team consists of up to 2 students. Any construction violations end up tiering the planes, which means it will place below any planes that were not tiered. A few additional parameters. The propeller diameter is not limited like some prior years, but it must be installed on the plane and fit in the box. And you'll find, especially on the C division, that the box is the limiting factor on the propeller size. B division, you can get a fairly large propeller into the box. It can be built or purchased. Many kits use the Icara props, usually a 9.5 inch propeller. The plane must weigh a minimum of 8 grams without rubber, and this is fairly easy to reach. And so with the rubber motor, it's about a 9.5 gram flying weight. The plane or aircraft must be rubber powered with 1.5 grams maximum rubber mass. Whether it's a plane, a helicopter, or a glider, your rubber is limited to 1.5 grams. And this includes any O-rings or other permanent attachments on the rubber. You can lube the rubber before or after massing. I'd suggest after. And you can check in up to 6 rubber motors, or if you have an aircraft that uses multiple propellers or rotors, 6 sets of rubber. So this year's design, being a box constrained design, allows a lot of flexibility in design. A plane of any configuration, meaning a monoplane, which is your traditional airplane, a tandem where the tail surface is just as big as the wing surface, a biplane where you have 2 wings and 1 tail, even a triplane. A helicopter is permitted. There's a requirement that the helicopter have a dime-size surface at the top that would hit the ceiling, and the intent there is that the helicopter cannot impale itself into a ceiling tile to gain more flight. A glider is acceptable. The glider launcher must also fit in the box in the ready-to-fly condition with the airplane. The plane can be a tractor or a pusher. The propeller can be on the front or the back. It doesn't matter which way the plane fits in the box. You can use the long direction of the box for the wingspan, or for the model length. You can put the plane into the box diagonally. And this is one area that requires some experimentation to see what works for you, and that's the format of the wing. You're going to have flat with tip plates, which is in the top photo here. That's typical kit design right now. Dihedral, tip dihedral, or even polyhedral. An ideal wing has an elliptical dihedral shape for stability. Each of the sharp bends in the wing produce a little bit of drag. So all of these, including the tip plate design, in some way approximate an elliptical wing shape. The flight log is a requirement of the flight event, and a complete log is worth a 20% bonus on your time. So it makes sense to have a complete log. An incomplete log will still give you a 10% bonus. The log has to consist of at least 10 recorded flights. I strongly recommend you record every flight, and that you have well over 10 flights. We often, when we have gone to nationals, we arrive with over 500 flights. The required entries are the motor size, and that's not well defined, and that's on purpose. That can be the length of the loop, the width of the loop, the density of the loop in grams per inch, the mass of the loop. It's not clear. I recommend including all of those as parameters. The number of turns or torque at launch. So if you unwind after winding to peak torque, be sure that you report the turns or torque at launch, not at full wind. I do both. The flight time is required. Then 3 additional minimum columns, I recommend a lot more than this, would be the altitude the plane reached, and you can judge that by knowing the height of your gym and the height of basketball hoops and so forth. The torque, both the peak torque and the launch torque. The remaining turns or torque at the end of the flight. The number of unwinds from your full wind to near braking down to your launch torque. Details of the propeller, details of the trim of the airplane, the decollage, and so forth. Anything that you can adjust flight to flight on the plane, you should be logging. Logging is critical to improving your performance. The process for flying in this event, first of all, it's indoors. Don't let them put you outdoors. These planes will be destroyed by the wind at a minimum, possibly fly away if there's any lift. So it should be indoors, and the rules say the room dimensions are published in advance. If you're a week away from the contest and your coach has not received dimensions of the room, particularly the height of the room, but also the width and length of the room, they should be hounding the event organizers to get that information. A lot of times that's missed. Last year, one event that I helped coordinate, the initial publication of the flying space indicated it was a hallway 10 feet wide and 65 feet long. And that's just simply not acceptable for any plane with any kind of duration, because you need to circle around. And by having that published information, we were able to coordinate with the organizers and get that event moved to a better facility. Once the students enter the competition area, there's no coaching or communication permitted. The students can talk to each other, but the coaches and parents need to keep quiet. This is an ongoing issue. This is a student event, not a coach event. Only the participant may touch the plane or the box. This means don't let the officials attempt to measure or weigh your plane or box. This leads to damage and finger pointing and so forth. So the rules indicate the students are the only ones to touch the plane or the box. So the students should do the measurement with the tools provided by the event organizers. The flight log is 20% bonus if complete, 10% incomplete. We mentioned that already. There's a 10-minute flight clock, and this starts when the students are ready and the motor, rubber motor, is handed back to the team. So it's an unwound motor at that point. It's handed back to the team. 10-minute window starts. There's no timeout for retrieval or repairs. So if your plane gets stuck, you need to retrieve it on the clock or pull out your second airplane. Any flight starting in the 10-minute window may go to completion even if it exceeds the 10 minutes. Trim flights are permitted during the 10-minute competition window, but it doesn't stop the time, and it must be announced as a trim flight. Now, as an ES, I always ask the students, is this trim or is this official? But if the students fail to announce it, then it's automatically an official flight as soon as they release the plane. The score is the best duration of your 2 official flights plus bonuses. Construction violations end up placing behind all other flights that didn't have construction violations. Some of the things I've learned as an ES, some issues and some observations. First of all, insufficient logs is one of the biggest glaring errors. Only having 10 or fewer entries, 10 is the bare minimum. I consider that an insufficient log, but it passes the rule. I've seen logs come in with 5 flights. Too few columns. The rules require 6 columns of data. That means meaningless columns are not to be counted as data. Meaningless being, to me, date, flight number, plane number, things like that are not data. Logs are a critical element for improvement, and you really need to be looking at logs being your friend, not your enemy. Crooked construction. The kits have very good instructions, and if they're built on a flat surface, they will build well. We see a lot of untrimmed models that have clearly never been flown. You need to get in the gym. If you're going to spend $50 to $100 on a kit and build it well and have never flown it, you haven't done the primary part of this event, which is flight optimization. Heavy models, typically this is going to be too much glue. Watch your glue management, and we'll discuss that a little more later. Most planes that we see from kits are reasonably built, but they're not reasonably trimmed. They need to do a circle for any reasonable duration. You need to trim the plane for low power and then work on higher power for your climb up to the ceiling. And those adjustments are different than what you adjust for low power. And the final one is not flying the same in practice and competition. We see a lot of kids that know what their game plan is going in, but they see somebody else fly a really good flight and they get intimidated, they crank it up, they do something that they haven't done in practice, and the plane immediately dives into the floor because they're not flying it with the same settings that they plan to. So make a plan and stick to your plan. Some of the areas that you need to look at, the C division plane is still going to be a challenge, although with the changes in the box dimension this year, I believe it's going to be a little bit better to fly, but it's still going to be a challenge to trim. Therefore, the gym time becomes even more important, and looking at videos and documents online about how to trim the plane and what to do when it's doing certain things is going to be important. We've already talked about keeping detailed logs. Read and follow the rules carefully. So many kids come even into the state level competition not knowing the rules and having terrible violations on their planes when they come in. Read the rules, understand how it impacts your plane design. Use online resources, especially the Scioli Forum. Myself, Coach Brian, Coach Jeff, and several other experts are on there regularly. And look at the National Free Flight Society, the national sponsor of this event. Their website contains resources, both print and video, and we're continuing to develop resources and videos to help you out. Next section we're going to look at is sources, both for materials and kits, as well as sources of assistance and help. First of all, the kits. The official supplier for Science Olympiad is Ward Science. Their kit includes tools, glue, and everything to get you started, but it's basically a box of wood. It's not a design of an airplane. It's not any laser cut parts. It's a box of wood that generally applies to airplanes, and I think you get a plastic prop that tends to be on the heavy side. It will get you in the air, but it's far more open-ended than other kits. It's not as refined. The Freedom Flight Models kit is kind of the gold standard. He's been doing this for quite some time. These planes can be somewhat complex, but they're very competitive. They're consistently in the top 10 at nationals. The quality is excellent. The instructions are extensive, sometimes to the point of being overwhelming. A lot of kids will stop reading the instructions once the plane is built. You're only halfway through at that point. There's a lot of good information in the instructions on trimming and flying your airplanes. Freedom Flight also has a complete stock of accessories, including your winders, your torque meter, counters for the winder, rubber cut to custom widths, and options for propellers. J&H Aerospace also has very competitive indoor flyer designs. Generally, Josh has two different planes that he offers, an entry level and an advanced. The senior flyer is the entry level one, and it's simpler and easier to trim. It's got balsa leading and trailing edge. It's a straightforward airplane, laser cut. The Stinger has carbon for the leading and trailing edge. It's a bit more advanced in terms of trimming. It's got a little bit more wing, a little bit more stab, especially in C division. That makes for a little bit more challenge in trimming, but they're very good flying planes. Laser cut planes out of Colorado are a simple building plane. I can't emphasize that more than that. It's a very good flying design. Straightforward. It's also very low cost compared to some of the other kits. It's an all balsa kit, but it falls together. The pieces are all interlocking laser cut parts. You can build it in a few hours. There's photo instructions, no plans, because it's self-fixturing and builds itself. He does have two different designs, one for B and one for C. I highly recommend taking a look at laser cut planes for a simple, good flying plane. Retro RC is relatively new to the Science Olympiad offerings, but they have a complete line of both kits and parts, including winders and stuff like that. He's got a very competitive kit, and one of the interesting aspects last year is he had a biplane design in the lower picture here. I don't know that any of the other suppliers had that option. He also offers some propeller kits. So if you want to build your own wooden propeller, he's got kits available for that. So check out Retro RC. His prices are also very competitive at around $50 for a 2-kit package. So that's quite affordable, and I think it'd be a very good flying airplane. Guru Engineering is a nonprofit organization, so they have low-cost options as well. They have a Division B and a Division C version of their kit. Last year, their kits suffered a little bit in trimability. They were difficult to trim, probably because of too small of a vertical fin. So we'll see if they resolve that this year. And don't get locked into must have a kit. For a very low cost, quick build, the National Free Flight Society has put out a video this year of a super simple plane. Now the video focuses on a plane that would fit the B division rules, but it could easily be adjusted to fit the C division. Coach Brian built this plane on video in about a half an hour. It used craft store supplies from, say, Michael's or Hobby Lobby. Nothing special except for the propeller was an IKEA prop, and that would be the prop with shipping is going to cost more than the entire plane. He used grocery bag covering and regular to even heavy balsa, and built it under the 8-gram minimum. And it's a very simple flat airfoil plane built in less than an hour, and it flew 2-minute flights after a trim session. So for those schools that typically have spent $50 to $100 on a kit and then struggle to have worthwhile flights, this may be an option. It's super simple. You're not going to break the bank on it, and you can get in the air quickly and start logging some flights to even up to 2 minutes. Another source for plans is on the Hip Pocket Aeronautics website. Bill Gowan, a renowned indoor flyer, always has his Finney, and that's an annual design. I don't know if he's doing one this year, but the design is basically the same each year. He adapts it to the particular year's rules. So you can look at previous years. It's a carbon spar construction with tip plates, very similar to some of the kits. You do have to order all the parts yourself, but this would be a strong option for somebody who wants to scratch build or plan build a very competitive airplane. Accessories are available from a lot of these kit providers, Freedom Fly Models and J&H and Retro on here. In addition, we have Indoor Free Flight Supply. This tends to be higher end equipment, but they do have custom cut rubber, and I believe they have the smaller plastic winders as well. FAI Model Supply is a good source for rubber. That's the only source. That's where everybody gets their rubber. These other companies will buy the rubber in bulk from FAI, and they'll cut it to your size. FAI's rubber will only be at stock sizes. But they also usually carry the IKEA props, some prop hangers, and so forth. Volare Products doesn't have a kit for Science Olympiad, but they do have a lot of the accessories like propellers and winders. Indoor Model Specialties, Ray Harlan has covering, prop hangers, and most importantly, a rubber stripper. If you want to strip your own rubber sizes, it runs about $200. His website may not be up, and his website is up, but his ordering capability may not be up and running. You'll need to contact him by email if you're interested, especially in the rubber stripper. We mentioned the plans at Hip Pockets. We have a few plans at NIFIS as well. NIFIS has a Science Olympiad page that includes videos, plans, how-to guides, and other kinds of resources. That's an important page. That's intended to be a landing page for you to find links to all the resources to help you out. I can't overemphasize the Scioli online forums. This is the best place to go to for help. You'll receive help from other students, other coaches, And then Coach Brian, Coach Jeff, and myself are on there on a regular basis. And we far prefer you to contact us there than by email so that everyone can benefit from the answers we give. Hip Pockets Aeronautics Forum can receive some help there. And a few of the documents that have links from the NIFIS page that are critical to moving on in this event, minimizing weight gain and basic building techniques. Want to look at a few basic building techniques here. This really is starting the second half of the coach's clinic, and if you're time constrained, this is a good place to drop off, but we'll try and touch on some of the building techniques that'll lead to a successful plane at weight. Weight is everything, and glue control is important. I like to use thin cyanoacrylate or super glue using a capillary applicator. This capillary applicator is a small scrap of balsa with two pins that come almost to touching each other at their tips. You put a little bit of glue on a, say, a margarine container lid, and you dip the tip of this in and touch it to your joint. You need to have a good joint to begin with, and the glue will wick in and make a good joint with minimum weight gain. A lot of the kits say to use medium CA. I find that medium CA adds weight in a hurry. Last year, I helped a team that contacted me a week or two before regionals, and I went to their gym to observe and give some pointers, and their plane was 19 grams. This was primarily wood, glue. They had a lot of glue. They used CA, medium viscosity, to try and glue the covering on. They missed the correct glue procedures in the instructions, and that's where most of their weight gain was. They, after regionals, they built a new plane under my tutelage, and in about 6 hours building, 2 sessions, 3 hours each, they were able to build under 6 grams, and it included a built propeller. And this was a mid-school team. Balsa density is important. Most of what you find at Hobby Lobby is going to be 16 to 20 pound wood. 5 to 8 pounds per cubic foot is contest grade. That's hard to find locally, and it's really not necessary for Science Olympiad. You can be in the 6 to 10, 6 to 12 pound per cubic foot range and still build to weight. Most of the kits that we mentioned have very excellent wood, so wood selection isn't going to be a big issue. Use the fixtures or whatever the plans require to build straight. A foam board, 1/2 inch thick from Hobby Lobby, allows you to pin the parts down. Don't put the pins through the balsa, but put them in at an angle to hold the balsa down. In some places, especially a carbon-to-carbon joint, getting a strong joint with CA can be difficult. We like to wrap it with 1 or 2 wraps of sewing thread and just a little dot of thin CA, and that really improves your strength. Covering. Ultrafilm is used in most of the kits. It's not real cheap. Grocery veggie bags, not the upfront bags that you get at checkout, but the bags in the veggie area are an excellent alternative. They're a little heavier than ultrafilm, but they work well. You need to build your wood structure on your plans, and then build the frame shown in this lower picture out of scrap balsa. You could even use some scrap foam board or maybe even cardboard, something to stretch the film out on and set it up for covering. The film itself, I like to cut it with a soldering iron or a cardery, like a thread cutting cardery. They're made for the medical field, and they melt through the plastic, but most schools can have a soldering iron available. If you have to cut it with a blade, use a very sharp blade, but if it snags at all, it'll tear the covering. We ball the film up as small as possible twice, and this makes micro wrinkles on it. It's better than having large scale wrinkles. It gives it a little bit of stretchiness in all direction. You unfurl the covering by stretching it or combing it with your fingers in an outward direction. Never comb perpendicular to the edge of the covering, or you'll tear it. We attach it to the wood frame, the support frame, with Vaseline or lip balm, and then carefully stretch it to the edges, not super tight, just enough to get the major wrinkles out. Then spray glue 3M77, just a light spray, onto the convex side of the wing frame and stab frame. Do this on a big sheet of cardboard outside if possible. The spray glue gets everywhere. And hold the spray above, well above the surface, and just spritz quickly over it. It doesn't take a whole lot of glue. Could use a glue stick. The danger is you damage the components as you do that. Now you move the structure to this frame that's holding your covering, turn it over and drop it onto your frame carefully, onto the frame covering carefully. Make sure it's in the right place before you drop it, because as soon as it touches, it's stuck. It won't move. Allow it to cure for preferably half an hour or so, and then cut it out with a soldering iron. If you have carbon leading edge and trailing edge, move fairly quickly with the soldering iron. Don't dwell in one place, or you will damage the carbon. There'll be more building tips available online at the NIFIS website. Let's move on to flying, the important part of this. Trimming. First of all, you need to get your plane set up before you even get into the gym. Verify the mass. If it's underweight, put ballast on at the CG or wherever needed to get your CG, your center of gravity, to the point indicated on the plan. If you do repairs on the plane, adjust your ballast to keep it right at the 8-gram minimum weight. Set your decollage, typically 3 to 8 millimeters. I'd probably say 3 to 6 on this year's plans. And decollage is a difference in incidence between the wing and the stab. Now, typically on these kits, the stab is glued to the tail boom, and if the tail boom was put on straight, the stab has 0 incidence, meaning it's in line with the plane. And so all of this decollage would be in the wing. So measuring up from the motor stick, the front of the wing should be 3 to 6 millimeters higher than the back of the wing. Now, once you get into the gym, you'll wind the plane lightly, meaning 400 to 600 turns on the rubber, and then launch it straight ahead with a light toss, as shown in the top image here. Shoulder high toss is fine. And this is a low-powered flight, so the plane shouldn't climb much. What you're looking for is the character of the flight with this low power. If it stalls, that means the nose goes up and drops, goes up and drops. Then you need to decrease the decollage. But generally speaking, the first flight, it's going to slightly dive or fly straight. You want to increase the decollage. That means raise the front of the wing or lower the back of the wing until you get a stall, and then take a little of that out until the stall just goes away. That gets you to a critical trim for the CG location. Now, how do you know if you've got the right CG location? First of all, the kit should come with an indication of where the plane should balance. You can just hold it on a sharp edge like a ruler to see where it balances, and move your clay to get the CG to that design position. If you're building your own plane design or not happy with the kit CG, if the plane dives and it's got reasonable decollage, you can move the clay back. If it climbs, you can move it forward. However, if it's flying well, and it goes up and touches the ceiling and then dives, it means it's marginally stable. And here you would want to move the CG forward to get more stability and then retrim your decollage. If it hits a ceiling and doesn't drop at all, it recovers very quickly, you can try a more aft CG and again retrim it. And this might give you a more efficient flight pattern and therefore more time. We found with these planes, especially the C division, very small changes in the center of gravity make a big difference in the flight time. So that's certainly an area that you should record in your log and experiment with once you have a decent flying airplane. Trimming may take several flying sessions, so be prepared to spend some time with your trimming. After you've got the trim set for your low power flights, now you add more power. Work your way up and always wind as if you're in the competition, meaning you wind to almost braking and back off to a launch torque. But work your way up in launch torque so you don't instantly put it into the ceiling. If the plane rolls into the circle, so rolls to the left, at high power but flew fine at lower power, then you want to add inboard wing wash. That means raise the leading edge of the left or inner wing a little bit relative to the right wing, and this will keep the plane from rolling in. This was a common solution last year on some of the kits, and I think it particularly had to do with the tip plates being on the small side in order to fit the box dimensions, especially planes that go in the box diagonally. So if you're running a kit that fits in the box diagonally and has small tip plates, be ready to add some wash in. Adjust your circle size to fit in 50 to 60% of the gym size. You don't want to be banging the walls. You want to have some room for the plane to move if there's any air currents in the room. The rudder offset or the tail fin bend relative to the center line of the plane has the greatest effect at high speed, whereas tail tilt toward the outside of the circle has a greater effect at lower speed. So when you get to flying, record everything. You can't log too much. Change one thing at a time. Whether it's a torque or a small adjustment to your incidence or your tail tilt or so forth. Change it, log it, try it. Once you get a decent flying plane, the rubber prop combination is the key. You need to optimize that. You can change props, try different propellers, especially if you're building your own. But even if you have a stock prop, you want to adjust, be able to adjust the pitch. The Cara props are fairly easy to adjust just by twisting the root of the prop, which means you need a protractor-based pitch gauge to measure and log your pitch. The stopwatch tells if you've improved or not. We'll get a little bit more into the rubber and prop optimization in a little bit here. Another technique that's helpful, especially if your gym is smaller than the contest venue in altitude, is to fly half rubber flights. So you would have a 3/4 gram piece of rubber, and then you would have a small stick that is also 3/4 of a gram. And this stick would have a wire hook at the front and the back, and it hooks to the rear hook on the plane, and it hooks to your rubber at the middle of the plane. The length of the stick should be half of the length of your hook-to-hook length on the plane. When wound to the same torque as the full piece of rubber, you'll have half the number of winds, you'll get half the altitude, and you'll get about half the time on the stopwatch. The rubber length is half of what you would have for the full rubber, but it's the same width or density, linear density. This gives predictable higher ceiling performance. If you're climbing 10 feet with half rubber, you'll climb very close to 20 feet with full rubber. This is a lower risk, especially if you have girders instead of a smooth ceiling. It allows you to test a lot of combinations without risking your plane. It also shortens the flight, so you can get a lot more flights in a test session. The bottom line is get in the gym. It takes a lot of flights to win. A little bit about rubber winding. Rubber has what we call hysteresis. This means it winds up at a higher torque than it unwinds. There's some energy lost. So to fight hysteresis, what you need to do is wind the rubber almost to breaking. This top chart, you can see the rubber has a linear increase in torque as you wind it. And then as it gets near full, suddenly the torque goes sharply up to the point of breaking. Because you're winding, and then it comes back on the lower solid curve here. And in order to get the most out of your rubber, you want to wind almost to breaking and then back off rather than just winding up to your launch torque. You'll almost double the amount of winds in the rubber at launch when you do this. Because of this, you need to wind off the airplane, preferably with a torque meter, but not everybody has a torque meter. But to save damage to the airplane, at least put a small piece of wire or a pin or a small nail into a piece of wood and use that either handheld or clamped to a bench to wind your rubber and then transfer it to the plane after winding and unwinding. Count your winds and log your counts up to the full wind and then the number of unwinds down to your launch torque. Lubricate your rubber. The rubber will cut itself to pieces and it won't slide on itself, so you won't get nearly as many winds if you don't lubricate it. However, use silicone oil, which can be shock oil for RC cars, or use Armor All from AutoZone. Armor All original formula is a silicone-based oil in a water suspension. Put this into a Ziploc baggie, squish your rubber around in it, and that will lube it. You can wipe off excess with a paper towel, but you want to make sure it's lubricated. Don't use mineral-based oils such as WD-40. I've seen several teams show up at an event. They pre-lube their rubber with WD-40. They practiced with it. It worked fine, but then it sat in the oil overnight, and they went to wind it, and the rubber just shattered into lots of little pieces. So don't use mineral-based oil. You need to know what braking is, whether by number of winds or by torque. It's usually best to do it by torque. And you want to wind up almost to braking. And to do this, you need to break some rubber. You can make some short pieces of rubber, say a quarter gram of rubber, and wind that to braking, and then multiply that by 4 for your full piece of rubber. That's when you know where it breaks. You don't want to quite wind to that in practice then. And then you back off to your launch torque based on ceiling height. You want to stretch wind. If you just wind at the original length of the rubber or your hook-to-hook length on the airplane, you'll get very few winds in it. If you stretch it to 5 to 8 times its original length and then wind at least half of your turns at full stretch, you're going to get a lot more winds into the rubber. And this has to do with how the knots form in the rubber versus simple twisting of the rubber and just the organization of the knots. Each flight you'll evaluate the rubber. Your initial climb, your sharp, steep climb is going to be based on your launch torque. Your cruise, how well it stays up near the ceiling, is going to be based on your rubber and prop balance. And then your letdown is generally going to be dependent upon your rubber prop balance, but also if you have a flaring prop, it'll be based on how soft your flex is on your prop. Look at the turns remaining when you're playing lands. You can count the turns and log that, or you can just glance at the rubber and look at how many knots are in the rubber. We tend to like about a half a row of knots. If you have a full row or more of knots, then you need thicker rubber to get a little more power out and use up the winds that you're putting in. So let's talk a little bit about adjustments in flight. Make small changes once you get decent flights and record your differences. If the plane dives, you either increase the decollage by raising the front of the wing or the back of the tail, or you move the CG toward the back of the plane. Each of these will eliminate a dive. Moving the CG back also reduces the stability of your plane, so you can run into some stability issues. So you need to play these off against each other. If you find you're getting excessive decollage to get a smooth flight, then consider moving your CG rearward. If your plane is stalling, this means a climb and then dip, a climb and a dip. You want to do the opposite, decrease the decollage or move the CG toward the front. If it stalls only at high power, this isn't a major occurrence on Science Olympiad. You could add some down thrust. This means angling the propeller shaft slightly down. You can do the same thing by increasing the incidence of both the stab and the wing. So your decollage, your relative incidence between the stab and the wing remains the same, but the motor stick points slightly downward relative to wing and the stab. If the flight is otherwise okay, but the climb is limited, then you need to start looking at your prop and rubber combination. If it's simply struggling to climb, you might have a prop that's too big in pitch or diameter. I'm sorry. You can make sure your decollage is correct. Set your decollage to low power flying, and then try your high power. Don't increase your decollage to get a better climb, because you'll suffer in your cruise and letdown, and that's where most of the time of the flight is spent. If the plane tends to race in a circle with the left wing low, or even dive into the ground with a left wing low, add that left wing wash in. Twist the wing so the left wing is higher than the right wing on the leading edge. So that's an introduction to the flight event. There are plenty of resources online through the Scioli Forum and the National Free Flight Society website, Science Olympiad page. My contact information is on here for follow-up, but I prefer that you follow up on the Scioli Forum so that general questions get answered in a way that everybody can see those answers and everybody benefits. I hope you have a successful year. Now get in the build room, get your planes built, and let's find a gym and get flying.